Hi guys, it's me again, the guy with the subwoofer thing. I need to show you something before I go to the Fulcrum subs, which is up next. You might see some timing during that screen capture on the delay finder and find it odd because 50 to 60 milliseconds is not crazy if you measure subwoofers, especially on the far field mics. They were about 10, 12 meters from the back and the front of the array. But still 60 and 51 milliseconds might be a lot more than you expect. Well, there are a couple of things you need to know when you measure subwoofers. And the easiest way to show is via a processor output. So I got Smart 8 set up, and if I hit the signal button, the pinkish stuff comes around. If I hit measurement channel, you can see I'm not synchronized. Here you go. Hit the L button on my keyboard, and delta delay tells me it's 2.81 milliseconds. Right now I'm synchronized, so the latency of the Apex IntelliX2 processor is 2.81 milliseconds. Now let's implement a high pass filter. I got that set up at about the same frequency as I use on the Fulcrum subs, so enable. And now you see the phase trace changing. If I hit the L button again, no problem, still synchronized. Now let's implement a low pass filter on that channel. And I'm gonna use a Linkwitz-Riley 24 dB low pass filter at 80 cycles. And watch what's gonna happen, especially to the live impulse response. So the phase trace has changed dramatically. It's showing a lot of phase shift. At 80 cycles you're -6, which is actually supposed to happen if you implement a Linkwitz-Riley filter at that frequency. Same happens at 24, 25, something. But in your live impulse response, it looks like there's nothing happening. Looks like it's vanished. Well, it's still there, but you have to really zoom in on what's actually happening to time. Okay, so if I implement a low pass filter, timing will shift. And now let's change the timing where Smart is synchronized. So it's 2.1, which was the processor latency. Now let's go to this point, 6.5 something. If I change time to 6.5 milliseconds, you'll see Smart is suddenly showing a phase trace that's going flat at about 125 cycles. You can see it over here. Its phase goes horizontal actually, and at about 125 it still shows that these frequencies are late and these frequencies are actually in front. So this part would be somewhere over here in live impulse response. Okay, that's cool. Now let's go to 8.7, 8.7273 milliseconds. 8.7. Enter. Suddenly, I'm synchronized at 100 cycles. So this point on the live impulse response corresponds with this point of my phase trace. That's pretty cool. If I go to like 12.2 milliseconds, 12.25. Now the phase goes horizontal at the area of 60 to 70 cycles. So this point of the live impulse response represents 63 to 70 something cycles. If I go to 16.6 milliseconds, now the phase goes horizontal at 45 cycles. This part represents this part of the live impulse response. So the phase trace goes horizontal in the 45 cycle range, which is actually located here in the live impulse. And let's go over to 21.25 milliseconds. 21.25. Enter. And now phase goes horizontal in the 35 to 40 cycle range. If I hit the delay finder, it will synchronize at the 12.38, which was somewhere around 65. Well, this means synchronizing on a subwoofer can give you a lot of different times. It all depends on where the energy is going, where Smart finds the data. So if you try to synchronize on a subwoofer, don't be surprised if you see delay times on the delay finder right at about 20 to 30 milliseconds, even if your mic is 1 meter or 3-4 feet away from the subwoofer. It's quite normal that happens, because a subwoofer is a time-stretched device.